Hey everybody, in this video we're going to go over finding the center, vertices, and foci of an ellipse. So here we have an equation of an ellipse, x plus 1 squared divided by 100 plus y plus 2 squared divided by 64 equals 1. Let's go ahead and write out the equation of an ellipse that we will use. We have x minus h squared over something plus y minus k squared over something equals 1. Now because we're working with addition, these two can swap, but we need to identify our a squared and our b squared. With an ellipse, the a squared is always the largest value in the denominator. So in this case, the largest value is 100. So a squared is going to be 100. And that's important to identify which is the largest one, because our a squared is now over our x. So our equation is x minus h squared over a squared plus y minus k squared over b squared equals 1. Now, when our a is over our x, okay, that indicates we're going to have a horizontal major axis, which means it's going to look like this. So in the x direction it's stretched, rather than looking like this where in the y direction it would be stretched. Okay, so in this case we have a horizontal one. Now, we have a squared equals 100, b squared equals 64. Let's go ahead and use those to find a and b. So we take the square root of both sides and we'll get a equals 10 and b equals 8. Okay, now where is the center? Because we're told to find the center. Let's go ahead and show the work for the center in this blue color. So our center is at HK. Okay, center is at HK. Now, we always have x minus h for our h value, but here we have x plus 1, which means we would have to have x minus negative 1 to have a minus sign in our equation. So h turns into a negative 1, and k, for the similar reasoning, we usually have y minus k, but in this case we have y plus 2, so k is a negative 2. So negative 1, negative 2 is our center. Okay, now when we're trying to find our vertices, what do? Well, our vertices from the center, if you look at this picture over here, are going to be added onto our x value because our x value is what stretched the most. So our vertices, we add on to our x value from our center. And we add on a. So from our center HK, it becomes h plus or minus a is our x coordinates, and then k stays the same as our y coordinates. So for our vertices, we will have h is negative 1, and then we plus or minus 10, which is a, and then we have negative 2. So we have two vertices. Negative 1 plus 10 is a positive 9, and negative 2. So that's one vertice. And then our next vertice is negative 1 minus 10, which is negative 11, and negative 2. So there's our two vertices there. Now for our foci, we have a C sound there, so we need to find C for our foci because our foci happen right about here, totally approximating there. They happen inside of our ellipse, but close to the vertice, and they are stretched horizontally. We add to our x coordinate again. So we take h and we plus or minus c. And then we have k. Now what is c? C we get from the equation c squared equals a squared minus b squared. And this is the case for ellipses only. For hyperbolas we have a different equation, and we'll talk about that then. So our c value, let's do this down here, will become c squared equals 100 minus 64. So what is our c squared value? Our c squared value is 36, which means c equals 6. So our vertices, our foci, are going to happen at -1 plus or minus 6, and then -2. And those 2 points are 5, -2, and -7, -2. So that is how you can find center, vertice, and foci of an ellipse.